Hello and welcome back. We finally arrived at Honeybee Energy. So the next videos I will all dedicate to Honeybee Energy. In between there will be some other smaller videos about Butterfly, since there are a lot of questions coming in. And there are also some remaining questions for Honeybee Radiance. And as you know, I concluded that chapter last week with my first live stream Q&A session. Thanks everybody who had the time to join. For the people who could not join or missed it, don't worry, we will do that more often. I think it's a very good way to connect with the crowd and get some feedback. We will slightly organize it differently next time. I will gather questions beforehand, and then we do the Q&A where I answer the questions, and then maybe during the session there will be more questions coming in. The whole thing becomes more dynamic and also easier for me to come up with topics. Everybody starts somewhere. Yeah, I hope everybody's doing well despite all the crap which is going on. I know this is really difficult times at the moment. Currently researching on how I can set up fundraisers, but I don't have enough subscribers yet, it seems. Anyway, we might talk about this in future, but now let's go back to some free education, and I think that's also important. And let's continue with Honeybee Energy. We'll start small. We will start with a very small basic script. We will reset up a new model for everybody who hasn't joined the Radiance, Honeybee Radiance. So we will create a very simple model, a new one. So we will set it up slightly different, and then we will do a very simple energy study. There's nothing more to say. Okay, so this is my new model, or set it up beforehand, so we don't need to do this during the video. Ground level is bedroom, in-suite, bathroom, hallway, this two, storage, kitchen, and living room, and windows are just surfaces attached to these walls. They are not cut out, they are just attached here directly on the same plane as the wall, and that's how you set up windows in the Honeybee model. And then the upper level is the hallway again, bathroom, second bathroom, secondary bedroom, and in-suite bathroom, and study, and a terrace here. We'll use that. So it's a very simple model, but we need to start simple anyway. It could be even simpler, it could be just a box, but let's do something which has some realism to it. Let's load Grasshopper. So very quickly we will build this model. So for that we go into Honeybee, create room from solids. There are different ways to create rooms. Please check my older videos if you want to go more in depth. But let's place this here. Always takes a while for this to load. So we need a BWrap container. I can select everything. Oh, this is one way to do it. I mean, there are a lot of different ways on how you can set up your model, really. In the Q&A, by the way, I talked about the sample files. The sample files in the download folder, when you download the Ladybug tools, they have some sample files. So in theory, you don't need my videos. You could actually just learn it easily from the sample files. My videos are just an additional help, basically. Yeah, select all these. So now they're all here. What we first need to do is to intersect solids. So that makes sure that all intersecting faces or walls create subsurfaces in order to later be able to recognize that these are interior walls. That's how it works. That need to run, toggle. So that ran. It all works here. We could go in here and then separate the rooms again. It's a bit it might not the best way to do it. We could also select from the boxes, from in here, the solids which already have the split surfaces. We could select the same typologies or the same level. That might be even better. I think it's almost the best to separate each room in its own room from solid tool. I think that's the best way. So we can give each of the room the right program and construction set and name. Let's do that. With if you have it not installed. Oh, right. Not that I don't forget. Bifocals again. Always forget this. Terrible. Terrible me. So you can actually see what I'm using here. If you don't have it installed, I would recommend use human. There's a way to actually use, there's this incredible list selector. There's also, I think, if I'm not completely wrong, item selector I think Honeybee or Ladybug tools had also an item selector. Maybe that was in the past. It doesn't matter. But here we can actually see which one we are choosing. We have 14 different rooms, and let's make it like this. Now we can start. It's a bit crazy, but why not? So this is my, and I just place here a panel. Kitchen. Storage. So we're building a much more complex model now than in the past. It doesn't mean that you have to do that all the time. You can also do approximation and have a much simpler model as in the previous examples. But I thought maybe it's good to be a bit more, to really build a very, very detailed thing. So now this B-rep number 4, this is the bedroom ground level. I'm not saying that this is a perfect layout for a building, but it could be. It could be a typical one. Here we're choosing 4, 5. There's probably a more elegant way to do it. And that's it. I will also see if these namings will work. I had some issues with the naming in the past, but let's see. So now we have ground level, all ground level, and then we have the upper level. Works. So we have the hallway, bedroom number 2, staircase, ensuite, bed, bathroom, and study. Yes, that's perfect. And then here we have kitchen, storage, bedroom, ensuite, bathroom, hallway, and entry, plus staircase, and living room. Yeah, so we have 2 floors. And now I would run the adjacency. So I would think of which rooms have are connected. So for example, the hallway and the staircase are connected. They have no wall in between. So I can run the adjacency room depending on what I want to first have connected, which not. So I would say the staircase and staircase and hallway. So maybe I need to move this here. I plug in both here. This is staircase and hallway, and we need to run that. And we can call, we will say this is an air boundary, meaning that between these 2 rooms there's no wall, it's open. And then we can do the same, and actually from first level to the upper level would be also open. Yes, there are ways to do that. It's a bit complicated. We would separate this in 3 portions. Maybe let's do that. Let's be very realistic here. Okay, so we have set this. That's fine. So we treat the core of the building, let's say, well, let's call it core, as one object, and then we add everything else. So the hallways, it would be this one, and the entry, they would be connected, and they can all go here. It's more economic. Oh, not the report. Not the report. So now this becomes one big space. No, let's do it differently. The staircase, sorry. You can already see that's a problem. The entry and the staircase is open. There's only the stairs in between. So let's do this. That's one space. Let's hide everything first here. Makes life easier. As you can see, it's all not that simple, but you will understand soon what I want to get out of it. Okay, so hiding everything here. Now the entry and the staircase are connected. It's connected. They don't have these two ones. So I added the adjacent solver, and then I put this here into the model, and then let's look at that in a different way. I get the visualize wireframe, and then we get the visualize by type, and you can see now, okay, we have if I'm hiding this and I'm adding a mesh, check my interior walls, so there's no interior walls, I just have outer walls and the roof. That's what I want. But then what I also want is then these walls here become also air walls with the hallway. So I need to run the adjacency here again. Let's do this. Let's do this here, here. And now this is not going to be an air wall, but we need to run it still. So, and that also goes into here. So still no interior walls, but if I'm looking at ceilings, then I have a ceiling here, but here I don't have a ceiling. So that's exactly what I want. And interior floors same. So that ceiling on level 1 and an interior wall and the interior floor on that level. And then my roof is just on the top. It's exactly what I want. So you need to play with, you need to really think your adjacencies through in order to build it correctly. So I hope it's more clear. We have outer walls, we have no interior walls because this is all open, but we have this roofs and ceilings, and the ceiling only on this side because here we don't have an air boundary. The hallway on the ground level and the hallway on the first floor are divided by this floor. Now I can copy this again, and I run the adjacency between all these other rooms here on the ground level. No, that's not what I should do. No, that's also not correct. I have more steps in between. Now, I haven't actually solved this problem here, right? So I need to solve the adjacency between the hallway and the staircase. So now if I run this, I actually create interior walls, which are here, but I don't want them. So I would go here and create these also air boundaries. So I should have still, yes. So now it's correct. You need to run the adjacency always when you add a new set of rooms. So although we have adjacency already for these rooms, now if I put this in here, I should have roofs, but that can't be because we have some roofs, which is the terrace, but then other areas are no roofs. So we need to solve the adjacency between the floor levels first, the two floors, and then solve the adjacency with the core of the building. Becomes a bit complicated, but you will see, you will understand later on. So I can add this here. And sometimes it's just, testing what works, what not. Now we've added the lower level and the cores, if you can call it like that. I'll copy this here and I place this down here, and now we add the 4 rooms from the upper level. And then we need to see on how we need to solve the adjacency. If we might need to solve the adjacency between the lower level and the upper level first, and then, but yeah, let's see how that works. Maybe we can just add it here. That might work. I think that works. So now we can walk through all exterior walls. That's correct. All interior walls. That seems correct. Yeah. All roofs, ceiling. That's also correct. Exterior floors. Well, these are actually exterior floors because they are they touching the exterior, the ground. Interior floors, yes. Air walls, that's also correct. So this floor also becomes an air wall. And then we haven't added any apertures, and we do that now. And today we only add windows. We only add windows, and you can, and then we later on we refine everything with shades and so on. And how we're gonna do that? So windows, as I told you, they are these here. So we need, let's group these things together. So this is my ground level, core, opala, it's not all added. And first floor. Here we solve all the adjacencies between the ground level, the core, and the upper floor, and then we add everything to the Honeybee model. And then now we add Honeybee apertures, and that needs first geometry. So we can, these are my windows. I can also call them windows. Oh. Rooms. It's a bit stupid because it actually doesn't rename it. But yeah, these are my windows. In Honeybee Radiance, in the last script, I actually organized the script. We will do that as well, but not today. We'll do it another day. Now we need to add this here. And then again, we will go through these a bit more in detail, what we can do here. Add a name, panel, windows. We need this add subsurface. You can do that before or after. You could do it specifically to your room. That's also possible. Or you do it, you add it to the whole model. That's also possible. And then we can add this here. Now I can hide everything, and then you see they're already applied. All these rooms are windows are applied. I could look at this exterior walls and see that all my windows are applied. For the ones who saw the other videos, the Radiance videos, this should be already quite clear what we're doing here, but I want to still repeat it so it's more clear, and we haven't organized it in that way in the past, so I think it's a good thing. Why we do this, why we have every room separated, is that we can give it all a different program. So it's all about the program in order to make a very, very detailed energy model. We'll not go through the programs today, but this is just on how we set everything up. Windows. And here's our model. So again, we're not adding shades yet. That's for another day. We can look at all the items we added so far. Air walls, windows, where are the windows? Apertures. So that's what we have. And yes, and ground. Interior floors, yes, we also have that. We have interior walls as well. And you can, of course, set your own different colors if you want. But I just keep the standard colors. It's fine for me. It's not about beauty here, really. It's about set it up correctly. And then we will have this outer area, this outdoor space. I haven't yet thought about it, what we're gonna do, but it will be part of the whole energy modeling series. So we will look at that as well. So that's our model so far. And then now we run a very simple energy analysis. We can use the Honeybee annual loads, and we don't look at the properties yet. We don't look at the construction yet, schedules, and so on. That's all coming, but just for you to get a bit of a feeling of what we could do. As you know, in the Ladybug tools, everything with underscore on the front need to have an input. So it's a question if we can load the models. A list of Honeybee rooms for which annual loads will be computed. Now, that's the question if we can. I'm not sure if we can add the rooms just here or the model. Let's check. Then it would be strange to just set up the model and then you actually don't need it. Oh yeah, we need a E+ weather file, of course. I never know how it's called. Download. Yeah, this is the one. Panel. Let's put this also here to the inputs. So maybe it should be actually in the top. And maybe we put this here. Toggle. Let's look at where I'm from, or better say where I live. By the way, not always all the weather data here in here works, but yeah, that seems to work. I can add a relay just to keep things more overview. We can also turn this off so it's not always starting again. And then we can put this here, and I already get what we need here. We need to have the rooms. Make another relay because it's very handy. I love it. Yeah, works. And now you think, what's going on? Well, there's a report, and now we could look at the output. I mean, this is all just this is a very, very simple calculation, and where we haven't really looked at anything specific, but it's just to get started. And you can always then see the description of what it is. A list of numbers for the 4 to 5 output load terms normalized by the floor area of the input rooms. Units are kilowatt per hours per square meter. They are ordered as follows: cooling, heating, lighting, electric equipment, gas equipment, and so on. That's what we need in kilowatt hours for these items: cooling, heating, lighting, and electricity. And gas equipment and stuff we haven't really added. Also service, hot water, and so on. We haven't added this yet because we haven't added the programs. So that's going to be the next step. Basically, that's already a way on how we can start to set things up. Another way on how we can start is by using the Honeybee model to OSM. That's actually gives you more information. Here we can actually use the model. So we can use the model. Let's have a relay again. Model goes here, and then we need the E+ weather file as well. There are some extra simulation parameters measures. This option is just for advanced users of Energy Plus, so let's not use it. And then we need a write button. That's already done. Cool. And a run button. Now it does some crazy calculation. Let's have some sip of amazing Earl Grey tea. Done, and we can add a panel here. Let's see how that's just copy content, and can look at that. It gives you quite a lot of information just based on the very simple model we did, without any program, without any construction. It has just generic assumptions and construction already based into each of these rooms. So whenever you create a room, it already adds a generic data to it, otherwise it wouldn't work. That's why we actually get an output here. And well, I don't actually know what it all means yet, or I mean, I can just assume things. District heating, it assumes that it has district heating. District cooling, we don't have any air conditions yet set up, so there's nothing in yet. But yeah, so I think that's where we can start. A crazy amount of stuff it actually gives you. Wow. Okay. As you can see, it's gonna be crazy. Crazy to go through all this. It also says here that write the Honeybee model to an OSM file, OpenStudio model, which can then be translated to an IDF file and then running through Energy Plus. I'm not yet 100% sure why we need that. Honeybee run an IDF file through Energy Plus. we get the same output, so I'm not 100% sure why we need that, but we will find out in future. So whenever I put this in here, we add again the weather plus the e plus weather file, and then we run this and we get the same output, but for sure it has some reason. Yeah, so as I said, so next time we will look into how we can refine all this here with the basic properties, construction, schedules, loads, air condition, and then we look at all the simulations. And here, this is a very interesting area, is the UTCI and the adaptive comfort maps to generate, and this is works together with Radiance, so we need to get actually back to Radiance a bit and combine the energy modeling with Radiance. This is, for me, it's the most exciting, most interesting bit, and also how to read results and so on. Yeah, I hope this is enough for a first preview, and we will jump into much more detail in the next videos. See you very soon, hopefully.